We would like to describe in words the regions of R3 represented by these equations and inequalities. The first one is x squared plus y squared equals to 4. As you know, this is equation of a circle of radius 2 and it's at the center of the origin 0, 0 in R2. Okay, so in R2 we have this 2 and x and y. So this is in R2. But in R3 we have 3 coordinates, x, y, and z. But in this equation z is free. It means that we can have all the points on this circle, but the third coordinate can be any numbers. The third coordinate can be any numbers from negative infinity to positive infinity. So it would be a cylinder, okay, in R3. So it's in R3, it's a cylinder of radius 2 and the center is z-axis. Okay, if I want to show the graph, x squared plus y squared equals to 4 will look like this. Oops. Okay, there you go. You see? It's a cylinder of radius 2 and the center would be z-axis. Okay, there you go. That's a cylinder. The next one is x squared plus y squared equals to 4 and z equals to -1. So in this equation, I know that the region that I'm describing would be on the plane z equals to -1. So this equation in R3 describes all points on the circle x squared plus y squared equals to 4, but they are all on the plane z equals to -1. So how does it look like? If I want to graph it, it would be something like this. Let me try to graph it. This is x, this is y, and then this is z, okay? So I'm on the plane z equals to -1. So basically I'm somewhere in here. Let me graph the plane. Okay, so this is the plane z equals to -1. And now on this plane z equals to -1, I need to consider all the points that are on this circle. Okay, so it would be something like this with the radius 2 and the center at the origin. Okay, so let me show z equals to -1 as well. As you see, the z equals to -1, the plane would be the blue plane in here, and then I have all the points on the cylinder that lie on the plane z equals to -1. So it would be a circle on the plane z equals to -1. Great. How about the last one? X squared plus y squared equals less than or equal to 9. So whenever that we have inequalities and whenever that we have an inequality and we want to graph it, we need to first graph the equality. So I'm gonna first graph the equality and I'm gonna see what the equality is. So the equality is this cylinder. In R3, okay, In R2, it would be a circle of radius 3, but in R3, it would be a cylinder. So this is a cylinder of radius 3 with the center at the z-axis because z is free. Okay, and now let me graph this. The cylinder, this is x, y, and then z. I'm gonna have a cylinder of radius 3, something like this, and because z is free, it goes up and also it goes down as well because I have a cylinder, okay, of radius 3. Now that I have inequality, I need to see if all the points are on the cylinder, they are inside the cylinder, or they are outside the cylinder. Okay, so let me show the cylinder in here. Okay, so this is the blue cylinder, or basically purple cylinder, and because I have inequality in here, I need to see that I need to consider the points that are inside the cylinder, I mean here, on the cylinder, or outside the cylinder. So how can I choose? Basically, I'm just going to pick a point, okay? Now I'm going to pick the origin, and if the origin satisfies this equation, it means that the origin and all the points that are in this region, I mean inside the cylinder, they satisfy that equation. So let me pick the origin. I'm gonna pick the origin 0, 0, 0, and I'm gonna plug in into the equation. Y squared is less than 9. So z squared plus the second coordinate is also 0, z squared. So is it less than 9? The answer is yes, which means that the point 0, 0, 0, the origin, or any point that is inside the cylinder is on this region that I'm describing, okay? But if I pick another point, let's pick one point that is outside the cylinder. Let me pick a point like here, for example. What is this? The point can be 4, 4, and 0. Okay, now I'm gonna plug in 4, 4, and 0 into that equation. 4 squared plus 4 squared is it less than 9? So this is 16 plus 16, 32. It's not less than 9. Therefore, the points that are outside the cylinder, they are not described by this region. Okay? So I'm gonna say that this is all the points on, I mean, because we have equality as well. Okay, so on or inside the cylinder of radius 3 with the center the origin or the axis. Okay, so this region, the part C, describe all the points that are inside the cylinder and also on the cylinder.